Okay, this video will go through the process of solving a system of linear equations using the substitution method. So I'll start with number 7 on page 9 in your spiral notebook. So in number 7, you can see that y has already been isolated in the first equation. So I'll color code with red and blue. So the blue equation is already solved for y. So I take the red equation, and in place of y, I would write the 4x from the equation above. So I would end up with 5x equaling 5, x is 1. And now my job is to find y since I've already found x. So go back to either equation and take the equation that's the simplest to work with. And I think that y equals 4x is pretty easy to work with. I know that x is 1, so y equals 4 times x, which is 1, so y is 4. So the solution to this system would be the ordered pair x is 1, y is 4. Let's look at number 6 above. Has a different outcome, a little bit different outcome. So in number 6, once again, I'll color code with blue and red. So looking at the blue equation, none of the variables are isolated, but the x has a coefficient of positive 1. So I could take the first equation and I could solve it for x or isolate x. So that means that in the red equation, in place of the x, I would write 4 minus 5y, making that substitution, which is why this is called the substitution method. And now I can take this equation and solve this for y. So I have 12 minus 15y plus 15y equaling negative 1. I can see that negative and positive 15y sum to 0, leaving me with this false outcome or a false statement. When this happens algebraically, you conclude that this system has no solution because the lines are parallel. And it's hard to recognize in the format in which they're given, but if you analyze their slopes, and let me clear the ink and I'll show you how to do this. If we analyze their slopes, if you remember from standard form, the slope is capital A over B. So the first equation, A is 1, B is 5, so the first equation has a slope of negative 1 over 5. And the second equation, I'll do it in red, the second equation, A is 3, B is 5. So you can see that they both have the same slope. This simplifies down to negative 1 over 5. So the pair of lines have the same slope, meaning that they'll never intersect. So this solution would not have, or this system would not have a solution. So let's move on down to the pizzazz, page number 10, and let's look at a few of these together. Let's do number 7. In number 7, I would take the second equation and I would solve it for the x. So I would say x equals negative 2y plus 7. And I would take that into the first equation and I would make a substitution. So I would make a substitution for the x. So second equation would be negative 2, and I will write x as negative 2y plus 7 plus 3y equaling 14. So I'll solve this for y. So this gives me positive 4y minus 14 plus 3y equaling 14. So that means I have 7 y's equaling 28, and y is 4. So if y is 4, now I have to find x. So here, you need to find the x. And this is a process, so you just need to organize your work and find, just kind of, get the process going. So I think I'm going to use the second equation. I could use either equation, but I'll use the second one. And I know that y is 4, so I'm going to have this. 2 times 4 is 8. If I subtract 8 from both sides, x is negative 1. So the solution for the system given in problem number 7, x is negative 1 and y is positive 4. Let's do one more together on the video, and then I'll let you all just practice. Let's do number 12. Let's do number 12. Okay, in number 12, I don't have a lead coefficient of +1 on on any of the variables. So if I color code my equations with blue and red, I do have coefficients of -1. So if I take this first equation and I try to isolate the y, I could add the y to both sides, and I have this, 2x equaling y plus 16, and then I would subtract 16 from both sides, so y would equal 2x minus 16. So I could use that, and I could take that to the red equation, and I have -x plus 2y equaling -8. So I could say -x plus 2, and then in place of y, I would write 2x minus 16, and then carry on with that. So -x and let's see, that gives you 3 x's, and if I add, that's going to be 24, so x is +8. And then to find y, I'll just take this equation right here. If x is +8, so now my job is to find y, and I'm going to use 2x minus y equals 16. So I've said x is 8, 2 times 8 is 16. 16 minus y is 16. So that means that if I subtract 16 from both sides, -y is 0, which just means that y is 0. So the solution for the problems given in number 12 will be the ordered pair x is 8, y is 0.